Okay. Good morning. Are there anybody to listen to me? Are there anybody to listen to me?
Good morning.
Great, great, great. These are group number 3 and 4, right?
Yes.
Yes. Okay.
And 5.
4 and 5. Okay, now. Groups 4 and 5. Do you see this page? Lecture 8, valid arguments.
Yes.
Great, great. Yes. Now, I have a request. Скажу вначале по-русски. Сегодня я болен, у меня коронавирус. Вот. И горло там и так далее. Я буду говорить не так громко, как обычно. Может быть, это даже и лучше. Вот. Хорошо. И поэтому просьба выключить свои микрофоны, чтобы там нигде никаких фонов не создавалось. Итак. Да, итак. На прошлой лекции вы... Да. Сейчас вот здесь. Just a moment. Отлично. Спасибо. Now, group number 4 and 5. Do you see this text? Lecture 8, valid arguments.
Yes.
Yeah. Right. Okay. Now, just a moment. Here. Groups number 1, 2, 3. Do you see this page? Lecture 8.
Yeah.
You do.
Yes.
Right. Because now there are all kinds of tricks possible with this system. Okay. Yeah. Valid arguments. По-русски этот перевод valid arguments. Логически обоснованные доводы. Or in English, use of reason to decide something or persuade someone. So, use of reason to decide something or persuade someone. Definition. An argument is a finite collection, A sub 1, A sub 2, and so on, A sub n, of statements that are simple or compound, followed by a statement A. We denote an argument by the notation. Either this one, or this one, If we can squeeze our argument in one line, then we will use this notation. If this statements A sub 1 is long, then it is better to write it in a separate line, A2 in a separate line, AN in a separate line, and what follows is under the horizontal bar. The horizontal bar stands for the word. Therefore, that is why. So, or hence, so. Each of the statements, A sub 1, A sub 2, A sub n, is called a premise of the argument. A premise of the argument. The statement A is called the conclusion of arguments. So, note, in practice, we are interested only in arguments for which the premises are true. Because Arguments like, look here, A sub 1, a statement. My father is Alexander the Great. Is it true? Well, maybe. If it was written many centuries or millenniums ago, maybe. But the next argument, my mother was the English Queen Victoria, who lived in 19th century, just maybe 150 years ago. She was a long-ruling queen of England. So these are the premises, and therefore I am your present king. Oh, both of the premises are false for sure. Only such argument only make us feel pity for the insane speaker, insane, сумасшедший, for the insane speaker. Definition. An argument A sub 1, A sub 2, A sub n, therefore A is valid if whenever an assignment of truth values to the statement variables make the premises A sub 1, A sub 2, A sub n true. So here, these premises, if presented here, we cannot have a formula, but typically we have a formula with statement variables. Here, formula with statement variables, and so if whenever assignment of truth values to these statement variables in these formulas are true, make the premises also true. Then it also makes the conclusion A true. So whenever this is true, from it, if it follows that this is also true, then it is a valid. Valid. Вы знаете, что это valid? Это как бы правильный, исправный, действительный. A valid ticket, a valid ID card. Ну, так сказать, действующее удостоверение, действующий билет еще и так далее. Ну, valid argument. So whenever an assignment of statement variables in this formula and in this formula, they make the premises true. In that case, A is also true. In this case, it is a valid argument. Okay, we'll see from examples. Hopefully, it will be more clear. Another name and definition of a valid argument. So this is the first approach to start talking about it, and here another to make it more clear. What do I mean by argument and valid argument? Definition. Given a propositional formula G, and let A sub 1, A sub 2, A sub n be propositional formulas of G. If it is formula, then there are variables. Then the interpretation of G is an assignment of truth values. To A sub 1, A sub 2, A sub n. So each variable gets one truth value, true or false, in which every A sub I is assigned true or false, but not both. This is an interpretation. This allows us to speak in shorter terms about assignment of truth values to statement variables like this. And we will call it the interpretation of the formula. Okay. Definition. Given formulas f sub 1, f sub 2, f sub n, and the formula g, we have such formulas. G is said to be a logical consequence of f sub 1, f sub 2, f sub n, or logically follows. G logically follows from f sub 1, f sub 2, f sub n. If and only if, for any interpretation I, well, just say it is a set of truth values for each variable. If for any interpretation I, in which f sub 1 and f sub 2 and f sub n is true, in other words, each of these, in this interpretation I, each of these formulas is true. In this case, of course, this conjunction is also true. G is also true. Another way to say the same thing here. So whenever this is true, then this is also true. Another way to say the same, if f sub 1 and f sub 2 and so on, f sub n implies G is a tautology. So because whenever this is true, this is true. And if it is false, then we don't care what is the value of G. From false, it follows true. Now we may say that it is true and true or false, and it will be the tautology. This formula is a tautology. F sub 1, F sub 2, F sub n are called axioms, or postulates, or premises of G. If G is a logical consequence of f sub 1, f sub 2, f sub n, then the formula f1 and f2 and so on fn follows, implies G, is called a theorem. So this is a theorem. G is also called a conclusion of the theorem. Conclusion. So here we call this, what follows, we called it a conclusion. A is said conclusion. And here it is also called a conclusion. But if this is the we discuss it in terms of proving theorem, then it is postulates, and this the logical consequence or conclusion. In mathematics and in other fields, many problems are stated as problems of proving theorems. Example: consider the formulas f1, f sub 1. P implies Q. f2, f sub 2, not Q. And G, and G, not P. So it is necessary to show that G is a logical consequence of f1 and f2. Show that this argument, P implies Q, not Q, therefore not P, is valid. So different ways to say about the same thing, but I repeated it 2 times, just in hope. So how can we prove the validity of the argument? Method 1. By constructing a truth table, we can show that G is true for every interpretation where f1 and f2 is true. Or same as f1 and f2 implies G is a tautology. Look here. We have here such propositional variables, P and Q, everywhere, only two. These are interpretations of every formula. We have four interpretations of every formula that consists of P and Q, but we are interested in P implies Q and not Q. So here P implies Q, false and false whenever a premise is false. Here premise of the implication. It is the whole implication is true. From true, if we say that we make conclusion F, it is false. From true and true, it is also true. Okay. Not Q. So this is a truth table for the first premise. Here. This is a truth table for the second predicate. It is not false, true, not true, false, not false, true, and here. The both premises are true only for this interpretation. And we come here, okay, this, we say that and, when we combine both premises by and or conjunction, it is also true. For other interpretation, this is false. So both are interpretations, premises are true, and the conclusion is also true. What is here? We don't care. True or false doesn't matter. The main thing, premises are true, conclusion is also true. A valid argument. But now we can prove that such a formula, that is conjunction of premises, implication, a conclusion. Look here. From if true, then true, true. If false, then anything what is here, true. If false, never mind what is here, true. False, never mind what is here, also true. Okay. So you see, this is the convenience of defining the function implication and also the logical connector, as we did here, as we did before, that it is false only in a single case, when from true it follows false. In this case, we can conveniently interpret, define valid arguments in terms of this connector. If then it becomes, how to say, not contradictory. Okay, here you see both premises are true, then our conclusion is also true. And this formula is a tautology. Method 2, second method. Transforming analytically the formula P implies Q and not Q. From here implies not P to a tautology. We do it like this. Just a moment. P implies Q and not Q implies not P. The first thing that we do is, what is it? We get rid of this implication. Get rid of this implication. It is not the first formula or the second formula. Okay, we get rid of this implication. After that, we get rid of of this implication here, not P or Q. Only now we can apply the axioms or laws of propositional logic, because they are given for us only for disjunction, conjunction, and implication. And of course, not implication, sorry, and negation. Now, we have this, we open this bracket, not P and not Q, this thing, or Q and not Q. And after that, here we have or not P. Down. Now we see that this is what? Q and not Q. It is a contradiction. So this is presented by this constant C. It is any statement with this, which is always false for any interpretation. After that, we apply this negation to this P or not Q, this not P and not Q, sorry, not P and not Q. It becomes P or Q. This is gone, P or Q by De Morgan laws. Or not P. Not P. I left it. After that, I combine not P and P. Of course, it is a tautology. So tautology or Q. So tautology or any formula, the result is a tautology. Yes, that's it. So we came to the same conclusion as here. An argument that is not valid is called to be, or is said to be, invalid. Valid and invalid. Consider an argument. If you don't mind, I will. Consider the argument. P implies Q, one premise, P another premise, Q is the conclusion. An example of such an argument is as follows. One of the examples. If today is Saturday, then I do not have to go to school. P, today is Saturday. Q, therefore, I do not have to go to school. No, therefore, it is not part of Q. I just say it is better. It is better to delete this therefore. Therefore is presented by this parallel horizontal bar. It is better. I do not have to go to school.
I'm sorry, but your camera seems to be broken.
Well, I closed it because I'm coughing and so on, and I don't want to just to show my situation. Sneezing. I don't have to go to school. In order to decide whether this argument is valid or not, we consider the following truth table. Here we have only P and Q. P, Q, and P implies Q. So this is a premise, this is a premise, and this is a conclusion. But this is also, I decided not to make an additional column because it is here, same. So these are interpretations of these formulas. First interpretation, second interpretation, interpretations, okay, of this formula. Now, P and P implies Q are premises. P, premise P, is true here and here. This premise is true here. True here and here, but this premise, first premise, is false here. This here true and false. So there is one interpretation when P and P implies Q are true here. But in this interpretation, Q is also true. That's why it is a valid argument. It is the last line of the table that P implies Q and P are both true. But in this case, the conclusion Q is also true. Hence, therefore, according to the definition of the argument, the argument is valid. This simple but important argument is called modus ponens. Modus ponens. So actually, this is a scheme, a pattern of constructing valid arguments. First, if such a statement, the whole statement is true. After that, the premise of this statement is also true. Then we can conclude that Q is also true. It is, no, we cannot, how to say, say anything against such a solid proof, reliable proof. Example, arguments that look like modus ponens, but which is not. P implies Q. If today is Saturday, then I do not have to go to school. And the second premise, I do not have to go to school. And we are trying to use these premises to prove that therefore today is Saturday. Again, therefore maybe, I don't know. Well, I will leave therefore this so that you can understand that what we are trying to prove. Therefore is actually presented by this bar, but let it be. Therefore, today is Saturday. Is this argument valid or not? PQ, P implies Q. So these are interpretations of these formulas, of the premises. Here, both premises, in this interpretation and in this interpretation, both premises are true. Q, true. P implies Q, also true, because from false we get true, it is also true. From true we get true, it is also true. Well, but so we have two cases when premises are true, but the conclusion for one interpretation is false, and for one interpretation is true. What is our judgment here? That actually it is a wrong way to prove anything. It is not a valid argument, though it looks so, how to say, persuasive, so proving. So in these two rules, both premises are true, but the conclusion P takes two values. Hence, the argument is not valid. Law of syllogism. P implies Q. Example of a statement with this pattern. If today is Saturday, then library is open. Q implies R. If the library is open, then I must study at the library. So, therefore, we can conclude if both of these statements are true, then we must be able to conclude that this is also true. But, well, we have to check it if it is so or not. That's why let us check it. These formulas have three propositional variables, P, Q, R. P, Q, R. And these are interpretations of the formulas. All false is false, true, eight interpretations. Now, PQ, from false, never mind what is the value Q, it is true. From false, again, it is true. From false, it is true. From false, it is true. From true, false, it is false. From true implies from P implies Q. From true, false, it is false. True, false, false. True and true, true. True and true, true. Okay. Now we found which interpretations bring the value true to the first argument. Okay, now what about the second premise? It is true, true, false, true, true, true. Here. Okay. Here I marked the interpretations and actually rows of this table by these such arrows. When both premises are true and true, P and from here, P implies R. P implies R. From false, never mind what is it, it is also true. Here, from P implies R. From false, again, for the same reason, P implies R, it is true. From false, again, this is true. From false, this is true. And finally, P is true and R is also true here. Okay. On these interpretations, both premises are true, and the conclusion is also true. That is why this pattern of constructing a proof, logical proof, which shouldn't be, how to say, doubt, or put to doubt, that you don't prove anything. No, it is a very persuasive argument. The rows with the values true in both premises are marked with arrows. this important argument is known as the law of syllogism. It was one of the contributions to logic by Aristotle, ancient Greek philosopher, who lived in years 3084 to 3022. Actually, you see 62 years before Christ. До нашей эры. Frequently used rules for making valued arguments. Frequently used rules for making truth arguments. The argument rule are one premise. From here it follows, if it is true, then A or B is also true. So we can make a tautology for this argument like this. From premise and what is the conclusion, we connect by the implication. It is a tautology. We can make a table. These A and B are true when they are true. A and B. So this statement connected where premises are connected by and is also true. So we because here it is actually a tautology. A equal and B implies and B. Basically, this is what it says. Tautology. After that, A or B, one premise, and not B, and not A, sorry, not A, another premise. By the way, people, do you hear me all right?
Yes.
Yes?
Yes.
Because I thought maybe I just covered the camera, and maybe the sound also is muffled. No. So we can make an application. A or B and not A. This is a conjunction of premises implies B. It is tautology. By the way, it looks simple, but we will see that this is a very, very, important method of proving logical consequences that is used in machine knowledge systems. Deleting disjunction or method of resolution. A and B implies A implies B. From here implies A. From here it follows. If this is true, then not B implies A is also true. We don't say that this is always true. We don't say that this is also true. No. We say what we say here and everywhere, that in situations when this statement is true, this statement is also true. This statement is also true. That is why, so we can make a implication between the premise and conclusion, and it will be a tautology. Rule of contraposition. A frequently used statement. If we say, and I showed you, if we A and B, and many people just try to make their proofs by such a scheme. Therefore, not A implies not be. Nope, it doesn't imply anything. They are not equivalent. They are not equivalent. Not be implies not A. After that, not A. A implies B, and A, therefore B. Modus ponens, we discussed it. After that, A implies B, and not B, therefore not A. Therefore not A. It is modus tollens. The rule, name of the rule, modus tollens. Ponens and tollens. And finally, A implies B, B implies R. From here it follows, R implies R. Law of syllogism. Law of syllogism. Okay, people, if you don't mind, let us have a break. I'll drink something, something warm.
Okay.
Okay. Let us continue our discussions. One more example. Is it a valid argument? If I am hungry, then I do everything quickly. One premise, I do everything slowly. Hence, therefore, I am not hungry. Our common sense says that the argument is logically sound. The formal notation for the argument is as follows. A implies B because I'm hungry, let it be A. I do everything quickly, B. I do everything slowly, not B. So A implies B, not B. Hence, therefore, I am not hungry, not A. We do. We list interpretations of these formula, of these three formulas, actually truth values of variables A and B. After that, here A implies B. Here is true, here and here, not B, here and that's it. And that's it. Both premises are true on a single interpretation, A, F, B, F. But the conclusion, not A, is also true here. So here, so it is, this argument was built by the pattern of modus tollens. Argument is valid, our conclusion. Example, is the argument valid? Argument valid. P implies not Q. Implies Q and not R. This is one premise. So three variables. P implies not Q, another premise. And the conclusion that we want to prove is Q and not R. Solution. It is a valid argument since it becomes from the argument P implies Q, comma P, therefore Q, of which you remember it was modus ponens method. So this comes from modus ponens by replacing P by P implies not Q, P implies not Q, and Q by Q and not R. Here, Q, this and this are equal, and here are also equal. So it is modus ponens. Example. Just a moment. I will just. Now. Example. Is it a valid argument? If number A is 18, then A is divided by 6. Well, true. Why it is true? Because we know it from early school years. Yes, 18 is divided by 6. If A is divided by 6, the same number, then A is divided by 3. We know it is also true. Also true from school. Therefore, if A is 18, then number A is divided by 3. If number A is 18, then this number A is divided by 3. Here it is the statement A is 18p. A is divided by Q is presented by variable Q. Here it is Q, same, by 3 R. Therefore, P divided by A. It is valid because it is syllogism. P implies Q and Q implies R, like here. And here, some home assignments. Please to practice a bit. For example, here P implies Q, P implies R, Q implies R. Prove your answer by a table. You must say valid or invalid and prove your answer here. And here the same, you have to introduce the statement variables, and after that make formulas, and after that prove, decide if it is a valid argument or not. Now, an interesting topic, rather abstract, Boolean algebra. We discussed already two-valued Boolean algebra, but it is a more general look at what is Boolean algebra and algebra in general. Before that, we said, I gave you an approximate definition, if you remember. Algebra, it is a set of objects plus set of operations that manipulate these objects. Here we will just give a more, how to say, sophisticated or complete definition. We studied 3 examples of algebras: set algebra, 2-element Boolean algebra, and propositional algebra. The properties of these algebras were very similar. It is not by chance. The fact is that these algebras are special cases of more general type of algebra, Boolean algebra. Definition. A Boolean algebra is a 6-tuplet. Tuplet. It is это упорядоченная последовательность. 6-tuplet. Это упорядоченная последовательность из 6 элементов. Tuplet is used, this word is used not frequently, but here it is just a proper place to use it. 6-tuplet. So 1, 2, 3, 4, 5, 6. The 6-tuplet, B capital plus, well, asterisk. Well, I forgot. Well, let it be style, let it be asterisk. But I am not sure that it is asterisk. The 0 and 1, where B is a set on which 2 binary operations are defined, plus and multiplication, as if multiplication. Just 2 symbols for 2 operations, and a unary operation, complement, denoted by these asterisks. 0 or 0 element and 1 unit element denote 2 distinct or special elements of B. 2 special or distinct elements of B. So within this set, we have 0 and 1, but you will see what kind of 0 we have. It might be, what might not, how it can be interpreted. The following axioms hold for any elements A, B, and C from this set B. In the Boolean algebra, of course. Commutative laws, A plus B, B plus A. A multiplied by B, B multiplied by A. Second law, distributive laws, A plus A by B, A plus multiply A plus C. And here, A multiplied by B plus C, A by B plus B, A plus C. Identity laws, A plus 0, it is A by 1, it is A, identity. Complement laws for any A, from B. There exists element A prime. Actually, I forgot. We can call it also prime, but well, it doesn't matter. From B, such that. So again, for any element A in B, there exists A prime in B, element A prime in B, such that. So special element for A, such that A plus A prime is equal to 1, A by A prime is equal to 0. Okay, so you see, I mentioned only four properties, not 11 or something as we mentioned in previous types of Boolean algebra, cases of Boolean algebra. Precedence. First brackets, if any, prime, multiply, plus. But also what is important, the duality principle holds for a Boolean algebra. Other laws of the set algebra, propositional algebra, or two-element algebras, and are direct consequences of axioms A1 of these four. Others can be deduced, proved. And what kind of laws? Idempotent, absorption, De Morgan's, etc. are direct consequences of the axioms 1 and 4. Okay, and here I can show you how we can prove it. Theorem 1, idempotent law. Idempotent law. Look, do we have it here? And here it is. A plus A, it is equal to A. Or A by A, it is equal, it is so idempotent law, let it be I, it is double I. By A by A, it is equal to A. We don't have such a property here, but we can deduce it from this. How? Proof. We'll start with this. I statement. A equal A by 1. We will prove this. A equal A by 1. It is here. It is, wow. I had to Well, you will see. Please don't look at this. B3, I did not. I took from my previous study notes without just here. I will put it A by 1, 3, 2. Three dot 2. Yeah. 3, 2. After that, it is equal to A, and this 1 is replaced by A plus A prime. 1 here, 4, 1. Well, and so on. I will not correct it because still, oh, maybe just a minute. 4, 1. And distributable for just, what is it?
А можно спросить?
Just 2, 2. Just 2, 2. Just a moment. Да-да. Спрашивайте.
По прошлой теме можно, пожалуйста, спросить? Можете чуть выше пролистнуть?
Давай.
Там, где таблица была. С библиотекой. Да, с библиотекой. Вот чуть-чуть выше еще. Смотрите, вот вторая строчка. У нас, получается, сегодня не суббота, и библиотека закрыта, но я должен в ней учиться, и у вас это стоит как валидное. Это как понимать?
Сейчас, секундочку.
Ну, типа пятница, библиотека закрыта,
Сейчас,
но я должен не учиться. Как?
Секундочку. Вы имеете в виду вот эту строчку или что?
Да.
Да, вторую и четвертую.
Вторую и четвертую.
Чисто по логике они не могут
Раз,
быть
два,
валидными.
3, 4. Just a moment. Вы меня не сбивайте. Ага. Ну, хорошо, давайте вторую разберем. Значит, вот у нас всего лишь что есть. Формула P implies Q и Q implies R. Вот эти формулы. Вы согласны, что вот эти вот, вот это вот утверждение можно представить такой формулой?
Да.
P. Today is Saturday. It is P. Library is open. It is Q.
А почему не эквиваленции? То бишь, если сегодня не суббота, и значит библиотека не открыта. А если суббота, библиотека открыта. Это более как эквиваленция. Я не понимаю, почему импликация.
Ну почему? Если то, здесь же мы, смотрите, if today, then, это чистая, так сказать, импликация. А эквивалентность today is Saturday, if and only if library is open. Потому что это, как говорится, эта библиотека открыта только по субботам.
Ага, а если импликация, то она может быть открыта не только по субботам. Но суббота говорит нам, что она...
Ну да, хорошо. Если то она открыта, но может быть она открыта и в четверг, и в пятницу, и в другие дни. Но в субботу точно открыта. Все, что здесь сказано. Так. А потом, if the library is open, это уже Q, вот сюда. I must study at library, it is R. Вот вы согласны с вот этими формулами или нет?
Да.
Чтобы они представили вот это вот. Теперь я говорю, что высказывание которая получена вот из этих высказываний, вот под этой по вот этой формуле, оно является логическим следствием из этих, иными словами. Когда оба вот этих вот условия выполняются, true, то и это тоже true. Так, теперь мы переходим совершенно, так, забудем о том, о пятницах, субботах, хороший я студент или нет, должен я заниматься в библиотеке или нет, забудем об этом. А вот теперь смотрим. У нас есть P, Q и R. Вот три переменных. Вот они, P, Q и R. Мы перечисляем всевозможные комбинации значений true and false. Перечисляем всевозможные интерпретации. Интерпретации вот для этих формул. Потому что набор значений, вот этот набор значений, это есть интерпретация вот для этой формулы. И интерпретация для этой формулы и для этого. Так вот, смотрите, вторая формула. P implies Q. Здесь сказано, если мы изложено утверждение, вот что такое, today is Saturday, а оно сегодня не суббота, тогда Q тоже false.
То есть библиотека закрыта, да?
Секундочку. Но это означает, что вот эти вот высказывания совершенно не имеют никакого отношения к этому выводу, к этому утверждению. И уже мы давным-давно договорились, что если вот в высказывании, построенному по схеме импликации, вот давайте посмотрим. If today is Saturday. Вот, а сегодня есть четверг. Then library is open. А сегодня есть четверг, так? Но ведь тогда все, что нам здесь сказано, мы утверждаем, что это правильно. Что для субботы это правильно. Про другие дни ничего не сказано. Если это false, четверг, то мы ничего не можем сказать, библиотека открыта или нет.
То бишь, если у нас первое условие false, то нам без разницы, какое будет второе в импликации. Она может быть и открыто, и закрыто может быть. Мы не знаем, поэтому импликация будет true в данном случае.
Вот смотрите, вот здесь, смотрите. Я же вам вот здесь вот дал. My father was Alexander the Great. My mother was English Queen. Это вот посылки, наше утверждение. Но посылка ложная. И это невозможно. Но я могу быть, как могу быть вашим королем, так и не могу быть королем. Так, это, как говорится, никто не обращает на это внимания. Потому что ничего, такое утверждение не доказано. Вот. И поэтому, чтобы, как говорится, отвязаться от сумасшедшего, ну, хорошо, согласен, иди. Вот, это не только для сумасшедшего, а также для того, чтобы, вот, знаете, это в формальных системах оказалось удобно. Что вот здесь вот, если это true, и вот здесь вот, так, это будет true, вот, то оно, в конце концов, мы приходим, что во всех, так сказать, житейских, правильных, ну, понятных и приемлемых случаях, вот этот вывод тоже будет правильный, если оба вот эти высказывания правильны. А здесь мы не обращаем внимания. Мы просто чисто формально. Из посылки false ставим true. Мы так уже давным-давно еще в этой двузначной Boolean алгебре договорились, что из нулевое значение, из нуля следует единица, и все вот это вот значение этой операции единица. Так. Ну и точно так же. Это по определению функции импликации. Из ложной посылки что угодно можно заключать, делать какие угодно посылки. И все заключение истинное. Вы заметите. False и везде. True. А здесь чего же? Q. Здесь true было. Из вот здесь вот. True. А вот здесь вот вы можете, вот здесь где F. False – это true. Тогда все. Из Q, если false, true. False, true. Из true не может следовать ложь. False. Из true не может false. А здесь опять две ложные посылки. True and true. Потому что мы так определили вот это вот операцию, импликацию. И решили ее использовать для доказательства. Ну, увидели, что это удобно. Что она соответствует тому, что мы интуитивно чувствуем. С чем интуитивно согласны. Хотя... Так, ребята, кто-то там... Отключите, пожалуйста, микрофон. Кто-то там включил, и поэтому звук.
Ну, соответственно, третий ряд у нас невалидный, потому что с true не может следовать false, как Q и R, да?
Да, из false не может быть true. И поэтому... Нет, false,
Не-не-не,
true, а вот здесь...
я про QR, да-да-да. С true не может следовать false,
QR.
поэтому
Да.
у нас там
Да,
стоит false нельзя.
Да, совершенно
Все,
верно.
понял, спасибо.
Пожалуйста. Ой, что сделал? Ну ладно. Так. Да. Так вот, дальше я не буду переправлять. Если вам будет интересно, поставьте сами. Вот они тут. Вы найдете. Теперь А и А. A implied by A. Сейчас. Distributed law. Вот это. This. A by A
Прошу
prime.
прощения, а четвертая, пятая группа видит черный экран.
Я там куда-то нажал нехорошо. Сейчас, секундочку. I'm so sorry. Сейчас. Я там случайно нажал не на тот крестик, сейчас, loading. Да, и здесь вот showing только по одному.
Hi, nice to.
Да что такое? Just a moment. Четвертая группа. Скажите, пожалуйста, вы сейчас видите экран?
Да, видим.
Да, видим.
Хорошо. А первая группа и вторая, и третья видите?
Да. Yes, yes, yes.
Ну, хорошо.
Да.
Все, we continue. So we transform this into this by distributive law. This A by A prime, we have it is 0 plus 0, and after that or 2. И здесь identity, any formula here, 3-1. Any formula plus 0, it is A. Oh, yoki. 3-1. 3.1. Okay, so identity law. So this is a simplest. Here I have some other examples of proving theorems from actually laws of two-valued Boolean algebra. We have in that algebras normally we use more laws, more equivalent formulas, pairs of formulas, because it creates greater convenience for transforming. Because if we have only 4, then even to make a smallest transformation, we have to prove all the intermediate steps. And here I show 1 prime 0, 0 prime, it is like that. De Morgan laws, we prove them like that. Absorption laws, here is the proof. Okay, I will not now discuss it. I ask you to do it at home yourself. Now, the two-element Boolean algebra is stated like this. B is 0 and 1, plus it is or multiply, it is and prime, it is not 0 and 1. So the set B consists of only 2 special distinct elements. Yes, there are no other 2. The set algebra is a Boolean algebra. Here, B, it is P of U, power set of the universal set, the set of all subsets of the universal set. Operations, union, intersection, complement, empty set, and the universal set itself. The propositional algebra is a Boolean algebra where set of all propositions, logical connectives, or and not, and here special elements, which is a contradiction, any statement with this, which is permanently equal to false, and tautology, which is permanently equal tautology. Equal to 1, to true. Considering, now I want to conclude. Considering algebras from more and more general points of view, Mathematicians introduce more general types of algebras, such as lattices, решетки, groups, группы, semi-groups, полугруппы, rings, кольца, semi-rings, полукольца, etc. For example, a Boolean type algebra belongs to a lattice type, supertype, типу решетка, который является супертипом по отношению к Boolean algebra. А вот дома try and prove anything about it. Home assignment. Given algebra, a six tuple, D sub 70, and here A plus B, it is a summation of numbers. A by B, it is multiplication. A prime, 1 and 70. A prime, it is I will give a definition. Actually, did I say summation? It was a slip of tongue. A plus B, it is least common multiple, the smallest common divisor. Наименьший общий делитель, least common divisor, multiple of A and B. A and B, they belong. I forgot to mention that the set D sub 70, it includes such numbers 1, 2, 5, 7, 10, 14, 35, 70. Set of divisors of 70. And these A and B belong only to this set. This is why if I divide A 70 by A, the result will be also integer number. Yes. 10. Look, if I divide 70 by 10, result is 7. It is here. If I divide 70 by 14, it is 5. Result is here. It is like this. A. And so I just draw your attention to some facts of the definition of this algebra. A by B. It is greatest common divisor. Greatest common divisor of A of B. And A prime, it is such a number. 70 divided by A. 1 is 0 element. 1, which is here, is 0 element from this definition, from the definition of the Boolean algebra. Oh my God. And 1 is 70 is the unity element. So I give you a description or definition of this algebra. Why not? The question is it a Boolean algebra? Prove your answer. In other words, you can try these 4 statements. Like, how can you do? For example, here the first one, after that the first one, and after that check if the principle of duality holds. If it holds, then you can deduce from this, apply to this in this algebra all the other laws of, for example, two-valued Boolean algebra and so on for transforming formulas. Because here we will apply operations to get new numbers from this set, Okay, so prove your answer. You have to think about it, because just sitting and listening to it for the first time, it's rather even difficult to understand what is required. But I explain to you, and after that, please. The result of the operation should belong to this set also, of any of these operations. Up to this set. And here I give you some more exercises about the propositional logic, formulas, and for you to practice at home. Okay, please, people, tell me, do you have any questions?
Yeah, can you tell about B? What is B in exercise, in home task exercise?
B?
Yeah.
B, it is the first position. It belongs to the first position. Belong to the set B. And here, I denoted it by D70. It is divisors of 70, set of divisors of 70. It is the set B. And for that set B, we define these operations in such a way. Did I answer your question?
Yeah, maybe, yeah.
Maybe you have to think a bit. I said it's rather not that simple to grasp from the first glance what should be done, especially if you did not read at home these Boolean algebras and maybe try to find additional materials and so on. But actually, it is an interesting material. Okay, now it's time to stop the. I hope everybody registered your presence, and at 1:10, after 20 minutes, we'll have a consultation. I will answer questions today, since I don't feel all right, only about my subject. Okay. So, people, sure, just a moment. I want to say bye-bye for now.
Thanks
Maybe
for.
somebody else.
Thank you, bye.
Bye-bye.
Thank you. Bye.
Goodbye.
Thank you. Bye.